Okay, I think now it's recording. Perfect. All right, so yeah, so just to remind you the title of this section, so more about functions and their graphs. So I think Wednesday, last week, we discussed the piecewise functions. And then we had, I think we started the discussion about even functions. I think I gave you the definition and just probably we did probably one or two examples. So yeah, I will first remind you the definition of even functions, and then we're gonna do a couple of examples. Just to remind you first. So yeah, so Wednesday, last week we said, so function f of x is even, so it's called even if, so this is the definition of even functions. So if f of x, or sorry, f of minus x is equal to f of x for any x. Okay. So any function which satisfies this property, it's called even function. Okay. Now the idea is the following. So what does it mean, this definition, right? So the idea is actually the following. So if you have like so you have the graph of f of x. So you have your your x-axis, your y-axis. This is your x-axis, and here's your y-axis. And then on your x-axis, you have some numbers. Let's say 1, 2, 3, 4. This is -1, -2, -3, and -4. So what we are saying here, guys, f of minus x is equal to f of x. It means that x and its opposite, they have the same image. So for example, if your x is, let's say x is 2, all right? So when I say x is 2, the opposite of 2, positive 2, of course, well, that will be so -2, right? Minus x would be -2, right? Now, so what we are saying, so if f is even, f of -2 is equal to f of +2. So -2 and +2, they have like the same image or the same output. So in other words, like in your graph, so let's say for some reason this is your f of 2, right? This is like, this is this point here, right here. So this is like f of 2. Then -2, x equal to -2 have the same image. So f of -2 would be the same, gonna be the same. We're gonna have the same output y. Okay, so both they have the same. As you can see, this would be f of, this is like f of 2 or f of -2. Okay, so 2 and -2, they have the same output y. Okay, and this is actually true for any x, not just for x equal to +2, but for any x. So for example, if I pick a different number, let's say +3, then +3 and -3, they're going to have the same image. So this is like +3, and let's say this is this point here, right here. This is the image of +3. Then -3 going to have the same image. So -3 going to have this output y right here. Okay, etc. So for example, 4, let's say this is f of 4. Okay, then -4 is going to have the same image. Okay. So in this case, like the graph would be, the graph of f of x would be like, it's going to be like something which looks like this here. Okay, so this would be like, in this case, f of x, the graph of f of x. But the point here, guys, as you can see, the vertical axis, the y-axis is going to be like, so the graph is going to be symmetric about this y-axis. You see this vertical axis, this blue axis right here. Okay, so as you can see, it's kind of like a mirror for this graph, right? So like the points they have, the points on the graph. So for example, this point right here, you see the distance from of this point from the y-axis, this distance right here. Well, it's going to be the same distance from the vertical axis to this point right here. Okay, so this distance here, right here, is the same from the y-axis, so same distance. Okay. So that's why the even functions are kind of interesting functions, because their graphs, they have this property that they're symmetric about the y-axis. Okay, so so what we can deduce from this, so the conclusion here is that graphs of even functions, graphs of even functions are symmetric. Even functions are symmetric about the y-axis. Okay, and well, as you can see, like in this case, the graph, it's not really a parabola, right? So because I think I had some questions last Wednesday last week. Someone asked me if the graphs of even functions are always parabolas, and I said that's not true, right? So here's an example where the graph, it's not really a parabola. Thank you, Idris. I got you. Thank you. All right. So that's the idea behind the even functions, right? So the x and the opposite of x, they have the same image. Okay, the same corresponding output y. All right. Now, yeah, examples. I think I gave just one example last week. I talked about the graph of f of x equal to x squared. So let me give you more examples today. So examples. Well, let me just start with a very simple example, actually. So f of x, let's say, is x to the power 4 plus x squared plus 2, right? And I want to check if f of x is even. Okay, so we're gonna check if f of x is even. Okay, so whenever I want to check if a function is even, there are like basically, I would say, two steps. So first step is to compute or to evaluate f of minus x, and the second step, you have to compare f of minus x to f of x, and if they are equal, then f would be even. Okay, so so first step, step one, we are supposed to find or evaluate f of minus x. F of minus x. Okay, so just be careful, guys. This is this is f of minus x, right? So between parentheses, it's not x, it's minus x, right? So that's different. Well, I mean, in general, it's supposed to be different from f of x. But then in the step number 2, you're gonna compare this to, you compare to f of x. The f of x, which is, you know, your original function, right? And so if they are equal, so if, excuse me, any question? Probably not. Okay. All right. And if if they are equal, then f of x is even. All right. So let's do this. So here's this is my original or my initial function, right? This is my f of x. This one right here. This is my original function. So first step, I need to find f of minus x. So let's see how it works. Okay, step one, I need to find f of minus x to compute f of minus x. All right. So how do we do this? My advice for you guys, I mean, if you're not, I mean, you know, if you're not really familiar with, you know, substitution, my advice for you is first, write down your original function, which is f of x. So I'm going to write down f of x first, my initial function. That's x fourth plus x squared plus 2, right? That's my original function. Now, I want to find, or I want to compute f of minus x. So as you can see, guys, I just replaced x. So here's x. And what I'm supposed to do now, I'm supposed to replace x, this x right here, by minus x. So the idea is whenever you see x, you're supposed to substitute x by minus x, right? So like in your f of x, there's an x in here, right here, and there's this x squared, right? So there's another x right here, okay? So I'm supposed to replace both x's by minus x. So I'm gonna use circles here because we'll see, because of the minus sign, you're gonna need like parentheses. So yeah, here's another x. So I'm supposed to substitute x by minus x. All right, so I'm gonna put here minus x and here a minus x, right? Okay, now what's left is, so there's a power 4 right here. There's a plus, there's a power square, there's a square, and then there's a plus 2. Okay. Now let's let's compute this thing. So this is f of minus x again. So you see the circle is just like parentheses. Okay, you think of the circle like parentheses. So I have like parentheses, and inside my parentheses I have minus x. Okay, and then this power 4, it's outside the parentheses. Okay, because here, guys, you know, there's a PEMDAS rule. So you need to know which one comes first, the power or the parentheses, right? So plus, and then next, it's again parentheses, and inside parentheses, there's the minus x, and the square, it's outside the parentheses. All right, so plus 2. Okay. Now, we have negative x to the power 4, right? So that's like, just to remind you right here. So you have this negative x to the power 4, right? So this is supposed to be like negative x times negative x, etc., multiplied by itself 4 times, right? So it's like negative x times negative x times negative x times negative x 4 times. All right, and then of course, as you know, negative times negative would be positive, right? So like this negative, that would be positive. And then I have 2 negative signs right here, so it would be positive. So as you can see, the negative x to the power 4, that would be x power 4. Okay, and the same for negative x squared. Negative x squared, that will be negative x times negative x. So negative times negative again, that will be positive. And so the answer is just x squared. Okay. So what I'm saying, guys, is that, so my f of, let's come back to f of negative x. So this f of negative x. So we just proved that negative x to the power 4, that will be just x to the power 4. There's a plus, and then this negative x square, it's just prove that it's actually equal to x squared. So plus x squared plus 2. All right. I'm gonna just erase this thing right here. Okay, so that's how I compute my negative x to the power 4, etc. All right, so I got my answer. I got my f of, sorry. So I got my f of negative x, right? So we said it's actually x fourth plus x squared plus 2. So that's my f of negative x. All right. Any question about this step? This first step, guys? So you see how it works? All right, perfect. Now, that's my first step. I got my f of minus x. Now in this step number 2, I'm supposed to compare my answer to the original or initial f of x, right? So in step number 2, so we're supposed to compare this f of negative x with, you need to compare it with f of x, your original function, right? So let's see. Well, f of negative x, that's what I got. This is from my first step 1. All right, this is from my step 1. And we said this is actually equal to x fourth plus x squared plus 2. Now, what's f of x? F of x is just, that's the original initial function, right? So we started, this is my initial function, right? It's x fourth plus x squared plus 2. So then, so it's x fourth plus x squared plus 2. This is 2, of course. All right. Now, if you compare both functions, you see they are equal. They are the same thing, right? So the conclusion is that f of negative x is actually equal to f of x because they both are the same thing, right? So then, because of that, well, you can conclude, you can answer the question now, and you can say, well, f of x is then is an even function. So f of x is even. All right. Any question, guys? Now, before the next example, so in this example, it works. I mean, my function f is even. Let me just say one word about the function f. And this is actually why we are using this terminology of even functions. So as you can see, the powers of x in the function f, so we got like this x to the power 4. This is x squared. So here, the power of x is even, right? 4 is even. This is even. I mean, the power is even, right? Here, it's square. Of course, 2 is even, right? Well, my question for you is, what about this 2, this constant 2? What's the power of x there?
The 1.
Nope, because when you say 1, sorry, any other answer? No. So no, because when you say 1, well, x to the power 1, that'll be just x. Okay, but when you have 2, it's a constant, it's just a number, but actually you can write it like 2 times 1. And the thing is, 1, it's just equal to x to the power 0. X to the power 0 is equal to 1, right? Because any non-zero number to the power 0 is equal to 1. So this 2, you can write this 2 like 2 times x to the power 0. Okay, so this is like this 2 here. So this is like 2 times x to the power 0, because x to the power 0 is 1. And power 0, I mean, 0 is also even number, right? 0 is also even, right? The 0 is also even. So as you can see, all the powers of x in my function f are even. The 4, the 2, and the 0. They are all even. So that's why, we call such function of even function, right? So, so remark. So all the powers or exponents of x in f of x are even. Okay, so this is the reason why we call such a function even function, actually. All right, so let's do another example, one more example before the exercise. So an example where the function it's not even. But of course, not all functions are even, right? So if there are a lot of functions, I mean, infinite number of functions that are not, which are not even. Okay, so the example number 2, to show you an example where it's not a function f, it's not even. Example number 2. Okay, so let's take f of x equal to, let's go with x to the power 2x power 6, and then just take minus x. All right, and again, I want to check if f is even. And actually, you know, because of our previous remark, you know, in the even function, all the powers of x, again, they have to be even, right? So you can guess here that this function, it's, well, you see, there's a power 6. 6 is even, but this x here is like x to the power 1, right? So 1, of course, it's odd, it's not even. So we have like one even exponent and one odd exponent. So actually, when you know, when all the powers are not even, then the function actually it's not even. So in this case, if you want to take a guess, your guess would be that this function f is not even because there's a one power which is not even, right? The one, it's not even. So this one here, this is not even power, not even power. So if you want to take a guess, then that would be f of x is not, it's not even. Okay, now let's use a definition to check if f is even or not. Okay, but that's our guess. Let's say that this function f is not even. So again, what I'm saying is, if not all the powers are even, then the function is not even. Okay, if you have just one power, okay, it's like if you have like all the powers are even except one, then your function is not even. Okay, anyway, so let's see if this function, check with using the definition if this function is even or not. Okay, so so for step 1, as a step 1, we are supposed to evaluate f of minus x. All right, so let's start with, as I said, it's better to write down first f of x, your initial function, which is 2x power 6 minus x. Now I want to compute f of minus x. So as I said, just substitute this x. So here's x, and you want to substitute x with minus x. So there's an x in here, and there's an x in here. So the x is going to be minus x. All right, so there's a minus x here inside the circle. And then what's left is there's a 2, coefficient 2, and there's an exponent 6 minus. Right, and now we'll see the importance of the parentheses, guys. So this is like, so f of minus x is like, so now I'm gonna just use the parentheses instead of the circles. Okay, so this is like, so equal to 2 times, and because of the circle, it means that I have like parentheses. So this is like negative x between parentheses. This is power 6 outside. There's a minus, right? This minus right here. Again, parentheses, and there's minus x inside the parentheses. Now, this negative x to the power 6, right? This is like negative x multiplied by itself 6 times, right? And because the power is even, right? So then you end up with actually just x to the power 6, right? So again, you have negative x 6 times multiplied by itself 6 times, right? 4 times, 5, and then 6, right? And because the power is even, the minus sign is going to disappear. So like minus minus, that's a plus, minus minus, that will be a plus, and another minus minus, that will be a plus. Okay, so you end up with just an x to the power 6, right? So just the x to the power 6. So that will be 2 times just x power 6. And then there's a minus minus, right? This is minus minus. So minus minus, that will be a plus. So it's now plus x. Right? We have like 2 minus signs, guys, because we had the subtraction, and there's a minus x inside the parentheses. That's why we have like 2 minus signs, right? Because of the subtraction and because of the minus x. So yeah, so that will be my f of minus x. So that's like the answer of the first step. So f of minus x is 2x power 6 plus x. All right, so now we can move to this step number 2. So all I have to do in the step number 2 is to compare my answer to the original f of x, right? So compare, I'm gonna compare f of minus x to f of x. All right, so from the first step, my f of minus x is just, this is from step number 1. The answer from step number 1 is 2x6 plus x. Now, what's my original f? My original f is this, right? This one right here, right? F of x, it's 2x power 6 minus x. So 2x power 6 minus x. So 2x power 6 minus x. All right. And now, well, as you can see, f of minus x is different from f of x, right? Because we have one in f of minus x, you have plus x. So you can see here we have plus x, and here we have minus x, right? So they are not equal. And if they are not equal, then the conclusion would be that f is not even, right? So conclusion. So f of minus x, it's not equal. So this symbol here means not equal, right? Different, not equal or different to f of x. So the answer, of course, f of x is not. It's not even. Right? And that's exactly our guess, right? Remember we said, well, you know, if you want to check like if your function f is even or not, all you have to do actually, guys, is, I mean, of course, in the homework or in the test, you have to do all these steps. I mean, you have to use the definition, right? But I mean, if you want to just you know, check your answer, what you can do is just check the powers of x. If all the powers are even, then the function is even. If one of the powers, just one, it's not even, then the function is not even. Okay. Any questions so far, guys? Okay, perfect. All right, so here's an exercise for you. And then, of course, after even functions, we have odd functions. The idea is the same. Yes.
Sorry, I
Yes,
just
please.
it's
Please.
a quick question
Yeah,
regarding the recorded video.
Yes.
When
What
will
happened?
it be uploaded to Blackboard?
Tomorrow morning, for sure.
Okay, sounds great.
Yeah,
Thank you.
sure. And actually, you can subscribe on to my YouTube channel. But yeah, I will upload it tomorrow tomorrow morning for sure. Yeah. So here's an exercise. Right. So please check if f of x is even. And so let's have like 2 different functions. First function f, So f of x, let's say it's negative 2x to the power 8, right? Plus, let's say 4 x squared. Okay. Number 2, it's f of x equal to, let's say, minus x power 10 minus 1. Okay. So I'm going to give you a couple of minutes, guys, to think about this problem. Please try to follow these 2 steps. So in the first step, you are supposed to find f of minus x. And in the second step, you're supposed to compare your answer to the original function f. Okay. Matthew, yes, the answer for number 1 is even. Yes, you're right, Matthew. Yeah. I guess I guess your answers are based on the fact that from you're using the powers of x, right? But yeah, you're right, Matthew. That's correct. Okay, not by solving. No, what the thing is, I think next section, section 1.7 or something, we're gonna do a lot of substitutions. That's why I think it's better to practice a little bit now. Replace like x by minus x, because later, like in section 1.7, we're gonna do a lot of substitution. We're gonna replace like x by like different expressions. So it's just, I think it's good practice. I mean, it's good to practice. Yeah.
Hey, mister.
But the homework, like in the homework and the test, you have to write down all the steps. I mean, justify your answer. Yes, go ahead. Sorry.
For number 2, I said that it's not even, but the 1 has no x, so basically it's
sorry.
x to the 0 power.
No. Oh, sorry. You said not even. I thought you said
Yeah.
even. Oh,
It's
no,
even
it's
too.
even.
It
It's
is
even.
I meant to
Yeah,
correct
it's
myself.
even.
Because
Sorry.
it's a zero.
Yeah.
Yeah.
Yeah, sorry. Of course,
Both
it's
of them is
even.
even.
Yeah.
Yeah. Sorry. Oh, sorry. Yeah. Number 2, it's not even. Yeah, sure. Sorry. You're right. Sorry. I wrote not. Yeah, sorry. It's even, of course. It's easy. It's even. Yeah, as I said, for when you have a constant, like this 1 here, this is like 1 times 1, but 1 is also x to the power 0. Okay, and 0 is even, of course. All right, does anyone need more time? Okay, all right. So let's do this. So for number one, yeah. So if you want to guess the answer, then as I said, you can just check the powers. Actually, all the powers are even. 8 is even, 2 is even. So then the function f is going to be even. Okay, so but let's do this following the 2 steps. So first step, step 1, we're supposed to evaluate f of minus x. Right, so here's first I'm going to write down f of x, which is minus 2 x power 8 plus 4x squared, and then I'm supposed to substitute x by minus x. So this x right here by minus x. So here's an x, here's another x. Okay, so both have become minus x. Now we have this negative 2 in front of the x to the power 8, and then this is power 8 right here. This is a plus, and there's a 4 outside, of course, the parentheses, and then there's a square. All right, so let's do this. So f of negative x, that's negative 2 times, as I said, think of the circle as parentheses. So this is like parentheses, negative x inside, the power 8, it's outside. Again, that's really important, where you put the exponent, inside or outside the parentheses because of the PEMDAS rule. Now, plus 4 parentheses and a negative x, and then there's a square outside. Anyway, so the idea is that negative x to the power 8, because the power is even. So when you multiply negative x by itself 8 times, you're going to end up with just x plus x to the power 8. Okay, so so this is just f of minus x. So it's just negative 2. And as I said, this is going to be just x to the power 8 plus 4, and then this negative x squared, negative x times negative x, because of the negative times negative is going to be positive. So this is just x squared. Okay. So the answer here would be just f of minus x is actually negative 2 times x to the power 8 plus 4x squared. All right, and then step 2, if you compare this, f of minus x, that's what I got in first step, to the original f. My original f was just f of x equal actually the same thing. So then both they are equal to the same thing. So then f of x. So the answer is that f of x is even. Okay, because they are equal. For number 2, you're saying something, Jimmy? You're no. Okay. Okay, for number 2, step 1. So we're gonna evaluate f of minus x. Right, so first I'm gonna write down my f of x, which is just it's minus x to the power 10 minus 1. So minus x to the power 10 minus 1 minus 1. Now f of minus x. All right, so I'm gonna do the same thing, just substitute x by minus x. So here's an x. So this is just minus x now. So there's a minus outside, and this is power 10, and then minus 1. Right, so this is just, there's this negative or minus, parentheses, there's negative x inside, power 10, and then minus 1. All right, so now this thing here, negative x to the power 10, so it's like negative x multiplied by itself 10 times, and because the power is even, actually, you're gonna end up with plus. So plus x to the power 10. So this is just, so there's this minus right here, and then, so this thing here is just x to the power 10, and there's this minus 1. So as you can see, this constant here doesn't change, right? It remains the same because there's no x there, right? So, and yeah, so I got my f of minus x. So, and step number 2, if you compare it to f of x, so this is my f of minus x from the first step, and this is my original f. Original f is actually exactly the same thing. So then my function f is even. All right, so then, so answer, I mean, f of minus x is equal to f of x. So f of x is even. All right. And again, guys, in this f of x, as you can see, there's this power 10, which is even, and this constant here, this is 1, this is like x to the power 0. So 0 is also even. Okay, so that's why my function f should be even. All right, any question, guys? Nope. Okay, so now let's move to the odd functions. All right, so this is even functions. Of course, we got odd functions. So number 2, now odd functions. All right, so I'm gonna start again with definition, and then I'm gonna explain, the idea, what will be the consequence on the graph of the function f, and then we'll have some examples. All right, so first, let's start with the definition. So f of x is odd, is an odd function if, if f of minus x is equal to, so in case of even functions, right, f of minus x would be just equal to original function, is equal to f of x. Now for odd, f of minus x is gonna be equal to minus f of x. So the difference with the even functions is this minus sign right here. Okay, so that's the difference with the even functions. So in the even functions, as you can see in the definition of even functions, where is it? Well, right here, you see f of minus x is equal to f of x. Okay, there's no minus here in front of the f, right? But now for odd functions, there's a minus in front of the f. Okay, there's this minus. So this is, so let me just say it. So this is a difference with the even. So that the minus sign, that's the difference with even functions, right? Anyway, so now what's the idea? So let's see So what does it mean for f of x to be equal to minus f of x? So let's take the graph. So again, here's my x-axis. Let's say 1, 2, 3, 4, -1, -2, -3, -4. Okay. Now, so what we are saying here, guys, is that so for example, let's say x is 2. Okay, and the opposite of x, of course, minus x would be -2, right? So x is 2, its opposite is -2, of course. And what we are saying here by this definition of odd functions is that f of minus x, it's actually the opposite of f of x. Okay, so for example, let's say this is my x is 2, right? And this point is, let's say here, somewhere right here. Let's say this is, for example, 3 right here. So let's say this is f of 2. Okay, this is like f of 2. Now, what we are saying is that the f of -2, f of -2 is going to be the opposite of f of +2. So f of -2 is going to be, well, f of 2 here is actually 3, right? Now, f of -2 is going to be -3. So then f of -2 is going to be like -3 right here. Okay, so this is f of -2. So f of 2 and f of -2, they are opposite. So in the case of even functions, f of 2 and f of -2, they're going to have the same image, right? Like f of -2 would be here if f is even. Okay, so if f was even, then this green point would be the image of f of -2. All right, so f of 2 and -2, they would have the same image if f is even. But now for odd functions, f of 2 and f of -2, they're going to be opposite, right? So this is because f is odd, okay? Then they're going to have opposite images, right?
Professor,
Yes, please.
can you just scroll down the whiteboard so I can see the,
Down,
yeah,
like this.
perfect, thank you.
Sure. All right, so let's take another point. Let's say x is equal to 4. Okay, so here's, let's say this is right here, let's say 1, and f of 4, let's say it's equal to 1. Okay, so this is f of 4 right here. Now, f of -4 is going to be the opposite of f of 4. So the opposite, so f of 4 was 1, then f of -4 is going to be -1. So f of -4 is going to be right here, somewhere right here. F of -4, etc. And as you can see, well, in this case, the points, they're going to be like symmetric about the origin. So for example, you see these 2 points, because they are opposite, so they're going to be like symmetric about the origin. So what I call the origin is this point here, 0, 0. That's what I call the origin. Okay, that's my that's the point 0, 0. So these 2 points, they are opposite because they are symmetric about the origin, right? They have the same distance from the origin, right? So like you see this distance here from my red point to the blue one, it's the same as this one here, right? So the 2 points, they have like the same distance from the origin, from the 0, 0. Okay, the same thing for the other 2 points, right? Like these 2 right here. So you see right here, distance from this red point to the blue it's the same as this one here from the blue one. Okay, because they are opposite, right? And so the idea is that for the graph of odd functions, okay, the graph of the odd function is going to be symmetric about the origin, about the point 0, 0. Okay. So the remark here, so the remark is that, so the graph of an odd function is symmetric about the origin. And so the origin is just the point 0, 0. Okay. So for example, if you have another point, let's say right here, okay, then you're going to have another point which is of the graph, which is symmetric about the origin. So you're going to have a point which is somewhere, you know, you measure like the distance from this point to the origin, right, to the blue point right here. And so on the other side, you're gonna have another point right here. Okay. So the 2 points, though, this one here and this one, they have the same distance from the origin, from the blue point. Okay, so they are symmetric about this the origin. Okay, and so the graph is going to be, you know, just join all these points, and you're going to get the graph of f of x. Okay. Another remark, guys, is that for odd functions, if you compute f of 0, so remark number 2, you know, f of x is odd. And as I said, by definition, f of minus x is f of minus x is supposed to be equal to f minus f of x, right? That's the definition, right? Now, suppose that x is 0, okay? For example, what happens to f of 0? So f of minus 0, so here I'm saying, I'm gonna just check what happens to f of 0, okay? So let's say x is 0. So then f of minus 0 would be equal to minus f of 0. All right, but f of minus 0, of course, minus 0 is just 0. So what we are saying is that f of 0 is equal to minus f of 0. Okay. So which number, so what you are saying here is that f of 0 is going to be equal to its opposite. So which number it's equal to its opposite? Of course, 5, it's not equal to its opposite. I mean, the opposite of 5 would be -5, and 5 and -5 both are, but I mean, they are different, right? But there is a number which is equal to its opposite, which is, any guess which number is equal to its opposite? Well, it's a 0, because 0 is equal to -0 or -0, right? That's the only number which is equal to its opposite. So what we are saying here is that f of 0, because it's equal to, you know, to -0 or negative f of 0, then f of 0 has to be equal to 0. So what we are saying is that for odd functions, if f of x is odd, then f of 0 must be equal to 0. So conclusion, if f is odd, then f of 0 is equal to 0. It has to be 0. Right? So like here in this graph of f, because my function f is odd, then f of 0 is going to be just 0. Okay. All right, guys. So let's do one example. Well, let's take f of x equals to negative, let's say x cubed minus x. Okay, and let's check if f of x is odd. Of course, we know how to check if f of x is even. Now we're going to check if f of x is odd, right? Well, we're going to follow the same steps. So first step, we're going to evaluate f of minus x. So step 1, we're going to evaluate f of minus x. And in step number 2, we're going to compare to not to f of x, but we're going to compare to minus f of x. We're going to compare to minus f of x, because if they're equal, if minus f of minus x is equal to this minus f of x, then f is odd. Okay. So this step number 2 is kind of, it's different from the, for even functions. In even functions, you have to compare to f of x. For odd functions, you have to compare this f of minus x to minus f of x. All right, so let's do this for this function f minus x cubed minus x. So first step 1. So I want to compute f of minus x. Okay. So this first step is the same for even or odd. Okay, you have always to start with finding f of minus x. So first, I'm going to just write down f of x minus x cubed, my original function, right? That's my original initial function, and then minus x, and then I want to compute f of minus x. All right, so yeah, so this x here becomes f of minus x. So this x right here becomes minus x, and this x right here is going to be minus x. So there's a minus x here inside the circles. All right. Now, okay, we have to be careful here because it's easy to get confused. There are a lot of minus signs. There's a power, so be careful, guys, with the PEMDAS rule. So this is a minus outside. There's a cube right here. This is subtraction. So here's my subtraction, right? Now, let's write down same thing with the parentheses. So there's a minus first, right? This minus right here. There's a circle. So think of the circle as parentheses. So parentheses, and then there's a minus x inside parentheses. There's a cube outside, and then this minus, and then parentheses minus x. All right. Let's do this. Well, first, you want to apply PEMDAS rule. So as you can see, guys, there's this minus outside parentheses. So you think of the minus outside the parentheses as a subtraction. Okay, the minus outside parentheses just like a subtraction. And then, of course, there's a parentheses, and there is this power, exponent theory, right? I mean, if you want to use the PEMDAS rule, of course, the exponent comes before the subtraction. So first, we need to evaluate the minus x cubed, and then there's a minus outside. Okay, so first, what will be minus x cubed? Well, it's minus x multiplied by itself, of course, 3 times. And now, because the 3 is odd, well, this minus here, that would be a plus, but then we are left with this minus right here, okay? So minus x cubed, it's actually minus x cubed, okay? Well, you may say, well, this is just the same thing. No, that's not, because here we have parentheses, and here there are no parentheses, right? So that's a huge difference, okay? And again, it's just because of the Promdas rule. So, so yeah, this minus x cubed, it's just minus x cubed without the parentheses. Okay, so let me just erase this. So what I just said is that, so this f of minus x, so we have this minus first, and then what we are saying is that this thing here, this is actually minus x cubed without the parentheses. Okay. Next, well, as you can see, there is a minus x. So minus would be a plus. Okay. So here we're going to have a plus, right? Because, you know, minus is just a plus x. So plus x. Okay. So so this f of minus x is actually equal to, well, there's this minus, and there's this, let me just write it again. There's this minus x cubed without parentheses, and then there's this plus x. Again, I got plus x because there's this subtraction here, and there's this, you know, there's a minus x inside the parentheses, right? Now, of course, there's 2 minus signs here. Minus again is going to be a plus. So this is actually a plus here. Okay, so we end up with, so this f of minus x turns out to be just, so this f of minus x is actually just x cubed plus x. Okay. So that's why, guys, as I said here, we can easily get confused because there are a lot of minus signs. So please use parentheses. Otherwise, it can be a mess. Okay. All right. So so that's the first step. That's my f of minus x. Now second step. Number 2. I'm gonna compare the answer from the step 1 to the original, not the original, but we need to compare it to, as we said right here, we have to compare it to minus f of x, not the original function, but the opposite of the original function. Okay, so we need to compare it to minus f of x. And again, why do I have to compare them? Because by definition, if they are the same, then f would be odd. Okay, so we need to compare the answer I got in the first step to minus f of x. All right, so from the first step 1, my f of minus x, so this is from step 1. So from my step 1, I got x cubed plus x. All right, that's from my step 1. Now I need to compare this to minus f of x. So minus f of x, my original function, the opposite of my original function. Right, so then that will be equal to, so so there's a minus, of course. And now f of x, what's f of x, the original function? It's actually, where's my f of x? Right here, here's my original function f, right? This one right here. It's minus x cubed minus x, right? That's my original function. So minus x cubed minus x. So I'm gonna put my original function between parentheses because this minus, you see this minus right here? This is supposed to be applied to the whole function f, right? Not just like the first term of the function f or the expression of the function f, but it's supposed to be applied to the whole function f. So we need to put the parentheses between, put the function f between parentheses. So here's my parentheses, and inside the parentheses, I'm gonna put my function f. So my original function f was minus x cubed minus x, right? This is my original function, f of x. Okay, now, as you can see, guys, because of the parentheses, so minus f of x is gonna be, there's this minus x cubed, so there'll be a plus x cubed, right? This minus right here, and this minus, there'll be a plus x cubed, right? And then you have to apply, I mean, it's like you have to distribute the sign, right? So minus minus, there'll be a plus, and then there's another minus right here. So there'll be another minus minus. So that'll be plus x. Okay, minus minus, that will be plus. So it's a plus x. Right? So you have to distribute the sign, guys. Now you compare f of minus x to f of minus f of x. So as you can see, so this is f of minus x. That's what I got from the first step. And this is minus f of x. And as you can see, they are exactly the same thing. They are equal. So the conclusion is that so f of x is, f of minus x is, so this f of minus x right here is the same as minus f of x with the minus outside the function f, right? Minus f of x. Exactly the same thing. So then, so f of x is odd. Okay. And as I said, like, so you can do the same thing like for even functions. If you want to check your answer, all you have to do is check the power. So as you can see in this example, my function f, the powers of x are all odd, right? So, my function f was minus x cubed minus x, right? So here the powers is 3, that's odd. And here the power, it's x, but you can write x as like x power 1. So of course 1 is odd, right? So all the powers here are odd. So then your function f is, that's why actually your function f is odd. So all exponents or powers of x are odd. So that's why actually your function f has to be odd. Okay. So yeah, so that's the idea, guys. So if all the powers are odd, then function f is odd. If all the powers are even, then the function is even. If you have like one odd power and another like even power, then the function it's neither. Okay, so this is my next remark. So remark number 1. So remark number 2. So if you have like, let's say f of x equal to x to x power 5 minus x squared, right? So in this case, you see 5 is odd, 2 is even. So if you want to check if this function is even, then the function actually f, it's not even. And if you want to check if it's odd, then the function it's not odd. So then the function f is neither. So this f of x, for example, So f of x here is neither even. Okay, because as you can see, you have both. You have odd powers and even powers. Okay. All right, so let's do an exercise. Check if a function f is odd. So exercise. So please check. So check if it is odd. So for number 1, number 2, let's have two different functions. So number 1, let's have just 2x5 minus 2 x squared. Okay, for number 2, let's have let's say 4x power 7 minus let's say x cubed. Okay. Oh yeah, I'm gonna add another one, number 3, so you can see what happens if I add a constant. So same as number 2, I'm gonna add plus 1, or plus 2. Okay. Bayesian, you're saying, so 1, it's neither. That's correct. 2 is odd. That's correct. 3, it's odd. No. So 3 is actually neither. That's because, as I said,
Because one is the even,
yes, absolutely. So this constant 2 here,
the two got like an even exponent.
yes, yes. When you have a constant, so it's like an even, you have like even power there, because that's like 2 times 1, and 2 times 1, it's like 2 times x to the power of 0, and 0 is even. So yeah, Bayesian. So yeah, so first it's neither, it's correct. Then odd, it's correct, but then the third one, it's actually neither. Well, I said I'm going to talk about domain and the range today. I don't think we're going to have time. I mean, if you have like very specific questions, guys, about the homework, I can probably answer them like in the last 5-10 minutes. Because I don't think I'm gonna talk about the domain and the range today. I won't have time, I guess. Yeah. So I mean, we are almost done with this section 1.3. So next, I'm gonna move to the section 1.7, and in section 1.7, we're gonna discuss again the domain and the range. So I have to remind you like all the, the how to find the domain and etc. range, all the notation. I think some of you had trouble with the intervals notation. So yeah, I thought I probably were gonna have a chance to start the section 1.7, but apparently not. Yeah. Anyway, so yeah, probably the last 5-10 minutes, if you have like a specific question about the homework, I can try to answer them. But otherwise, guys, if you have trouble with the homework, again, just email me. You can take an appointment, or you can just come to my office hours, and they're online on Zoom today from 2 to 3, and Wednesday from 2 to 3. Just send me an email if you cannot make it. Or again, there's this online tutoring, and if you need the link, just send me an email. Actually, the link it's in the syllabus. I think in the bottom of the second page in the syllabus, you can find the link to the online tutoring. So I'm probably gonna just solve one of them. I won't solve all the 3 functions, because we won't have enough time, I guess. So yeah, well, I can do all of them. Let's see. Okay, well, I mean, anyway, 2 and 3, they're almost the same. So yeah, I can probably do all of them. All right, so, well, does anyone need more time? Just be careful of the minus sign. Again, my advice is parentheses when you have like negative x. I would say like when you wanna like for odd functions, sometimes it's kind of tricky, with all the powers, and then there's a minus outside, and so sometimes it's just a mess. So you have to be careful with the steps. Just yeah, take your time. All right, so yeah, let's do this. Okay, for number 1. So as Bajan said, actually number 1, it should be neither, because 5 is odd, 2 is even, so it's like a mixture of odd and even powers. So then yeah, the function is neither. But let's follow the steps and see if this is true. So that's step 1. So as I said, in the homework, guys, or in the test, we need to, use the definition to check if the function f is odd or even. If you just use this powers trick, then you won't get like 4 grades. If you like, your justification is, well, all the powers are even, then the function is even. You won't probably get the full credit. Okay. So yeah. So first step 1, so we have to find f of minus x. All right, so let me write down f of x, which is 2x5 minus 2x squared. Now, f of minus x, okay, so x is gonna be minus x. So this x right here is gonna be minus x, and this x right here is gonna be minus x. All right, now outside we have like 2 here. This is power 5, there's a minus, there's another 2, and then there's a square. So in other words, if I use parentheses, this is 2, parentheses minus x power 5, minus 2, parentheses minus x square. All right, so parentheses first, Pandas rule, parentheses first, and then exponent. So we have to do the exponent now. So like this negative x to the power 5, because 5 is odd. So that's like negative x multiplied by itself 5 times, right? Because 5 is odd, then the answer is going to be negative x to the power 5. So, so this f of minus x is going to be 2. And now this is minus x to the power 5 without the parentheses. Okay. And then there is a minus 2. This is negative x or minus x squared. Minus x times minus x. Minus times minus is positive. And so this minus x squared is going to be plus. So this thing here, so it's going to be plus x squared or positive x squared. Okay, that's because the power is even, right? So if you have negative x to, if the power is even, then it's going to be positive x squared or positive wherever. If you have an odd power, then you're going to end up with a minus. Okay, now, so this is actually f of x minus x is equal to, so I'm going to just move this minus, this minus here to the front. So that will be minus 2x power 5, and then minus 2x squared. All right, so that's my f of minus x. So that's my f of minus x. So it's minus 2x5 minus 2x squared. Step number 2. Oh, sorry. So step number 2, I'm going to compare this to minus f of x. So compare it to minus f of x. Okay, so what's minus f of x? Minus f of x. So f of x, that's my original function or initial function. Okay, so this is equal to minus, and as I said, guys, you need to put your function f between parentheses. That's really important because you have to distribute the sign later. Okay, so I'm gonna put the minus, my function f between parentheses. So what's my function f? It's just my the 2x power 5 minus 2x squared. Okay, and now I'm going to distribute the sign. So so this minus goes right here, and then I'm going to have minus minus, and that will be a plus. Right, so that will be equal to, so it's minus 2x power 5 minus minus, that will be a plus. So right here, I'm going to have a plus. All right, 2x squared. Okay, so what we are saying is that minus f of x is minus 2 x power 5 plus 2x squared. So we need to compare this to the f of minus x, the answer from the first step. So as you can see, this is the answer from the first step right here, f of minus x, and this is my minus f of x. So this question is, are they equal? Bayesian, you're saying, why did you move it x as the minus? Which minus, Bayesian?
You know, like the f minus x, it was 2 minus x raised to the power 5, right? But then when you were writing the final answer, you put the minus in front of the minus.
From, yeah, because, yes, because, yeah, that's, you see this x, so this negative x to the power 5, right? And we said that's negative x multiplied by itself 5 times. So we got this minus right here, right? Minus x power 5. So yeah, you need to move the minus to the front. So that's why I got this minus right here, because I just moved this one here to the front.
Okay, so whenever it's like an odd function, you need to move it if you have an exponent in the beginning of the equation.
Yeah, just move to the front. Yeah. Yeah, absolutely. And then and now, yeah, as you can see, the two functions, I mean, the two answers, I mean, for the first step, the f of minus x is different, right? The here we have minus, and here we have a plus, right? So they are different, they're not equal, and so f, it's not. So the answer, so f of minus x is different or not equal to minus f of x. So f of x is not even. Sorry, it's not odd. And of course, it's actually it's neither, right? We said, I mean, if you want to check if function f is it's even, then it won't be even, right? Because as I said, because of the powers, so it's actually it's neither. All right, so that's for number 1. For number 2, what was the function f? Yeah, for x7 minus x cubed for x7. So number 2. So step 1, want to find f of minus x. So f of x, my original function, it's actually 4x to the power 7 minus x cubed. I want to find f of minus x. So I'm going to substitute x with minus x. So this x right here with minus x, and this x right here with minus x. All right, so let's put the 4, there's a 4 in front, and there's this minus right here, and there's this cube. So I forgot the power 7, sorry. Yeah, so that will be 4 parentheses, negative x inside the parentheses, there's power 7 minus by parentheses again, and then there's this cube. You see, the thing, guys, I mean, what you need to really to understand and why the parentheses are important, you know, if I didn't have parentheses right here, let's say I didn't have like parentheses, right? Okay, so if I don't have parentheses, you know, you're gonna have like minus, and that will be, oops. So you're gonna have like minus, and that will be just a plus, right? This minus here, and that will be just a plus if you didn't have the parentheses. Okay, but because of the parentheses, you have to do the exponent. So let me just right here. So we have this minus, and this is minus, and we have this parentheses right here. So because of the parentheses, we need to do this exponent first before applying the minus. So you think of this minus as like a subtraction. This is like subtraction, okay? And this 3, of course, it's exponent. So PEMDAS rule, you need to do exponent first. So that's why the parentheses are important, because otherwise, if you didn't have the parentheses, so it's gonna be just you're gonna have like minus x cubed. I mean, I have my x cubed right here, and then this is just a plus. Okay, but that's not the case here. So we do have parentheses, so that's why they are important. So that's here. All right, so let's do the exponent. So this is f of minus x. This is 4. Now, this is negative x to the power 7. So this is like, this is like negative x multiplied by itself 7 times, right? 7 times negative x 7 times. 7 times. Right, and because it's 7 times, if you count the how many minus signs you're gonna have like 7 minus signs, right? And so because 7 is odd, you're gonna end up with a minus x to the power 7 without the parentheses. And then there's this minus right here. Okay, and then as I said, we need to do this minus x cubed, which is multiplying minus x by itself 3 times. And again, minus x minus x minus x is going to be a minus x cubed. So this thing right here, so this thing here is going to be minus x cubed, but without the parentheses. Now, because it's without the parentheses, then I can apply minus, that will be a plus now. And as I said, like in the previous example, as Bayesian asked, so this minus right here, you see this minus right here, you can move it to the front right here. So that will be f of minus x will be like negative 4 x7, and it's a plus x cubed. Okay. All right, so then step 2, let's compare it to the minus f of x. So step number 2. So we need to compare this answer to minus f of x. So as you can see, the minus is outside the function f. So minus f of x, let's see. So I'm gonna write this f of x with the blue color. All right, so I'm gonna put, again, you need to put the f of x between parentheses, okay? Otherwise, I'm sure you're gonna get the wrong answer, because as I said, you need to distribute the sign, minus sign. So inside the parentheses, I have my original function f, which is the initial one, which is 4x7 minus x cubed. All right, so we're gonna distribute the minus. It's like minus, you think of the minus like -1, right? This minus here is like -1 times, right? You're multiplying by -1. So you distribute, so like here, you're gonna have a minus, and then here, that's a minus, that'll be a plus. So your minus f of x is gonna be minus 4x to the power 7, minus would be a plus x cubed. So that's my minus f of x. So if you compare this to the f of minus x, the answer from the first step, this is the answer from the first step, f of minus x, and if you compare it to this, the minus f of x, then as you can see, they are exactly the same. Matthew, why do we distribute the negative for each? For your Matthew, are you talking about the f of minus x or minus f of x?
X of minus x.
F,
What
f
I do
of minus
is distribute the negative to each x. So like x to the 7th power times negative. So it'd be like -4 times. I guess mine is more complicated than what I think. It's more simple.
Yeah, you have to distribute the negative. Yeah, you have to distribute the negative. So like like what I did right here, I distribute the minus sign, right? But that's different from f of minus x. So f of minus x, Um, so when you say f of minus x here, so this minus, it's not, it's, you're multiplying the x by the minus. But here, minus f of x, we are multiplying the whole function f by minus. So that's like, that's why we have to distribute here. We have to distribute the minus sign because, so we're multiplying the whole thing, the whole expression by this minus, which is like -1, right? So you have to multiply like each term by this -1 or minus. Okay, so that's why here we have to distribute the minus sign. Okay, here you just substitute x by minus x. There's no, it already distribute the minus sign here. Okay, here it's just here there's no, you're not multiplying the whole f by minus, right? You're just multiplying x by minus. That's different. Okay. But here you distribute, as I said, because you're multiplying, I'm multiplying the whole function by minus, which is like -1. So I'm multiplying each term of the function by -1. It's like multiplying each term of the function by +2 or +3. So negative, think of the negative like -1 or -1. So multiplying each term of the expression or of the function f by -1. So yeah, and so then yeah, so then the answer, the conclusion here is that f of -x is equal to this minus f of x. So f is odd, as expected, right? So remember, guys, we said that all the powers here are odd, so we expect f to be odd, right? Okay, for last one, oops, oh wow, okay, just 4 minutes, okay. For number 3, guys, I mean, it's almost the same as the number 2, and the number 3, f of x was 4x to the power 7 minus x cubed, right? And then there's a +2. Right, I think +2. Anyway, so when you do f of minus x, so step 1, you just replace x by minus x, right? This is almost the same as we did like in the previous example here, right here, right? You just replace x by minus x, but then you have this +2. But in +2, there's no x in +2, right? So you don't really change the +2. You just keep the +2, right? It's just the same thing. So what I'm saying is that from the first step, f of minus x is gonna be just this, almost the same as in the previous example or previous function. So it's gonna be like minus 4x7 plus x cubed. You see, that's what I got in the previous example, and then there's this +2, and again the +2, there's no x, so just I'm gonna just keep the +2. It's just the same thing. Okay, it doesn't change because there's no x. Okay, so it's just the same thing, minus 4x7 plus x cubed minus 4x7 plus x cubed. But then, as I said, for the 2, it's just I'm gonna just keep the 2. There's no x there. Now in the step number 2, so we need to find minus f of x. We need to find minus f of x. So there'll be a minus or like -1. I think again, I'm gonna write, instead of minus, I'm gonna write -1. I think it's better. So think of the minus like -1 times -1 times the whole function f. Not just the first term of the function f, but the whole function f. So the whole function f is 4x power 7 minus x cubed plus 2. That's my function f. So that's why So it's like multiplying by a number. And when we multiply like a function by a number, you have to multiply each term by that number. So here it's times -1, here it's times -1, and here times -1, right? Now, so distribute this negative minus sign, which is the same as like multiplying by -1. So for the first term here, you multiply by -1, or you're gonna have minus 4x7. For the second term here, minus x cubed, you multiply by -1. So it's like negative times negative, that would be a plus, right? So this thing here, this thing here is gonna be a minus, here is gonna be a plus. So that's plus x cubed. Okay, and then for the last term, you have +2, right? So +2 times -1, negative times positive, it's negative. That's why this plus here becomes a minus. So it's -2. Okay, so again, this is like distributing the minus, right? So it's like minus for x7, then minus x cubed, that'll be plus x cubed, and then like minus plus, that'll be a -2. Right, so that's, so my function f, sorry, not my function f, but the opposite of my function f minus f of x is actually minus 4x7 plus x cubed -2. And I'm done, guys. I'm just at 10 seconds. So that's my minus f of x. And I have to compare it to the f of minus x. All right. And as you can see, the difference is there's this +2 right here in f of minus x. And here it's a -2 or -2. Okay, so they are not equal. They are different, right? Because of the minus or +2. Okay, so the conclusion is that, so f of minus x it's actually different from minus f of x, and so conclusion is that f of x is not as expected. It's not odd, just because of the constant. All right, guys, thank you for listening. I have, I guess, to stop here. So yeah, we are done with this section. Next time, I'm gonna move to a new section. And yeah, I will see you in person on Wednesday, right? So, and please don't forget your homework. And if you have any question, please email me anytime, all right?
I'm sorry,
Thank you,
Professor,
guys.
excuse me.
Yes.
Hello?
Yes, yeah, I'm
Hi,
here.
no, I know I showed up a little late. I just want to make sure you took my attendance.
Okay. Okay, I got you. Thank you.
Okay,
Thank you.
and you have
Thank you.
office hours today, right?
From 2 to 3, yes.
From 2 to 3. Okay, thank you. Wait, is that on this Zoom or like
Yeah,
where
same
is that?
link. Yeah, always. I always use the same link. Yeah, it's always.
Okay. Okay, thank you. Bye.
Have to set up appointment with you if we want to see you at 2 to 3. Professor?